All right, so this video is about using special triangles to create what is called a unit circle. So the first thing we need is a circle. This is a circle. And the reason that they call it the unit circle here is because it is 1 unit long on radius. So the radius at any given point is 1. If I start here as this radius being a baseline, then we'll say that that is 0 degrees. And if I call that 0 degrees, then up to this point here, as long as that's perpendicular, is 90 degrees. Halfway around the circle, 180 degrees. 3/4 of the way around the circle, I'd be counting by 90s. So here's 190, 2 90s, 3 90s. That is 720 degrees. And if I count by 90s, 90, 2 90s, 3 90s, 4 90s makes 360 degrees all the way around the circle. So the location of 0 is the same as the location of 360 if I'm going around the circle. As a matter of fact, if I went around the circle twice, that would be 360. And then if I went around again, that would make 720 degrees. If I divide those quadrants then in half, then each one of those quadrants is a 90 degree divided by 2, that's 45 degrees, and then I could count around by 45s. Here's 1 45, 2 45s, this would be 3 45s, 3 times 45 is 135 degrees, 4 45s is 180, 5 45s is 225 degrees, 1 45, 2 45s, 3 45s, 4 45s, 5 45s, 6 45s, this will be 7 times 45, 315, and then 360 degrees. And we have divided the unit circle into 45-degree increments, which you know is one of our special triangle measurements. And we'll deal with that eventually here. We could also divide the 90-degree quadrant into 3 congruent sections of 30 degrees each. 90 divided by 3, 30 degrees. So if I started to count around the circle, there's 1 30, 2 30s, 3 30s. If I extend these lines in each direction, and throw some more lines on there from the other side, then I can count all the way around the circle by 30 degrees. So here's 30 degrees, 2 30s is 60 degrees, 3 30s is 90 degrees, 4 30s makes 120, 5 30s, 6 30s, 7 30s, 8 30s, 39 times, 30 10 times, 30 11 times, and 30 12 times gets me to 360 degrees. Here's the unit circle divided into 45 degrees and 30 degrees. And this is the unit circle completed with 30-degree increments and 45-degree increments. Now there is another way that we can measure, just like we can measure in centimeters or we can measure in inches, 2 units of measurement. We can also measure angles in either radians or degrees. And I am sure you're more familiar with radians than you are with degrees. So here's radians. 0 degrees. Now, all the way around the circle was 360 degrees. All the way around the circle in radians is 2 pi radians, which means halfway around the circle must be 1 pi radian, which means half of that must be pi divided by 2, pi over 2 radians. So now I can count by pi over 2. 1 pi over 2. 2 pi over 2, which reduces to pi. 3 pi over 2. And then 4 pi over 2. 4 divided by 2 would give me 2 pi. If I divide those into halves, then really I'm counting by 45-degree increments, but just like 90 degrees is the same as pi over 2 radians, 45 degrees will be the same as this divided in half. Pi over 2 divided in half. So if I want to do that, I have to take pi over 2 and divide that by half. That's the same as multiplying by 1/2. So I get pi over 4. So this location is pi over 4 radians. Now I can count by pi over 4s. Here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which becomes pi, 5 pi over 4, 6 pi over 4, and I really should reduce that. So 6 pi over 4, 6 over 4 becomes 3 pi over 2, 7 pi over 4, and then 8 pi over 4 becomes 2 pi. So we count around in radians just like we did in degrees. We can also count by increments of 30 degrees in radians. So if I divide this 90-degree angle, this pi over 2 radian angle, into 3 parts, then I get 1/3 of pi over 2. Pi over 2 divided by 3, which is the same as times 1/3, equals pi over 6. So this 30-degree angle right here in radians is the same as pi over 6 degrees. And now I can count by pi over 6's. This is 1 pi over 6, 2 pi over 6, which will reduce, to pi over 3. One pi over 6, 2 pi over 6, 3 pi over 6, and 3 over 6 becomes 1/2, so pi over 2. 1 pi over 6, 2 pi over 6, 3 pi over 6, this is 4 pi over 6. And 4 pi over 6 is reducible again. So even though it's 4 pi over 6, we know we'll reduce that fraction. The next one will be 5 pi over 6. Then 6 pi over 6, which reduces to pi. 7 pi over 6. 8 pi over 6. 9 pi over 6 is already reduced. 10 pi over 6. 11 pi over 6, and then finally 12 pi over 6, which is already reduced. So I guess I should go back and reduce these. 4 over 6 becomes 2 over 3, 2 pi over 3. 8 over 6 becomes 4 pi over 3. 10 over 6 becomes 5 pi over 3. And I think all the other fractions are reduced already. So again, just like we counted in degrees, we can count in radians around the circle. So now we have degree measurements and radian measurements. If we want to, now we can look at it and try to get coordinates for these. If I draw the 45-degree angle, remember the radius is 1, then what I end up with here really is a special triangle. It is a 45, 45, 90 triangle. I dropped the perpendicular straight down here. That means this is 45. And the coordinates of this are over a certain amount and up a certain amount in the x direction. Well, on a 45, 45, 90, if this side is 1, you can use your special triangles to find the other sides. It becomes the square root of 2 over 2 and the square root of 2 over 2. Which means this coordinate right here must be the square root of 2 over 2, comma, the square root of 2 over 2. This is the x direction of the coordinate and the y direction of the coordinate. A nasty coordinate, but that's what it is. So, a lot of other increments here. This 135-degree angle on the other side, if I was to drop down a triangle again the same way, a perpendicular line, at 135 degrees from here to here, that leaves me with 45 degrees here. Which means, again, I have a 45, 45, 90, and it is exactly the same as the triangle on the other side. Except that instead of being the square root of 2 over 2, this is in the negative direction. The radius is still 1. This is negative root 2 over 2. This is still positive in the y direction going up. So my coordinates look something like this. And the reason why these coordinates are there is because I can build that triangle from each location. Each one of those is a 45, 45, 90. 45 here, 45 here, 45 here, 45 here. The coordinates then, this should be negative square root of 2 over 2 because it's negative in the x direction. This one is negative in the x direction and negative in the y direction. This one is negative in the y direction only because I go over positive square root of 2 over 2, down square root of 2. Now we can do the same thing with the 30, 60, 90. If this is a 30-degree angle, then this is a radius of 1, then I can use my special triangles to find out the other sides of a 45, 45, 90. Again, I have a 90-degree angle here. So this would be root 3 over 2, and this would be a half, and my coordinates would be root 3 over 2, 1/2. We can do the same all the way around with these triangles. Why don't you, before this video ends, go ahead and fill in the coordinates at 30, at 45, at 60. So I want to know the coordinates of each of these locations. This point, this point, this point, this point, etc. All the way around the circle. Pause the video, please, and try that. And you can check your answer. It should look like this, with the coordinates filled in. We'll double check them in class. You can also go to Google and just type in unit circle, and there will be images there that you can double check also. The unit circle. I hope this gained you an initial understanding, and I'll see you in class.